Welcome to the recorded version of our webinar, Rise of the Machine Learning, Azure ML Brings Predictive Analytics to the Masses. My name is Greg Beaumont. I work for GNet Group, and it is May 21st, 2015. This webinar is a combination of two presentations that I've recently given. The first was TechFuse Minneapolis on April 21st. A link to the details about that conference is provided. And the second was SQL Saturday 396 in Dallas, which was a special BI edition on May 2nd, 2015. A link is also provided for that event. So what do I hope you get out of this session? First of all, an understanding of how predictive analytics, and specifically Azure ML, can add value to business analysis and to data analytics. Whether you're an experienced machine learning expert or somebody who's brand new to predictive analytics and machine learning, I hope you can understand what Azure ML is and how it's different from traditional machine learning tools. So if you've done machine learning and predictive analytics in the past, hopefully you can understand how this product fits into your toolbox. And if you're new to this discipline, hopefully you can understand how to get started and the types of problems that you can use it to solve. I'll walk through some examples of use cases, I'll go through a couple of demos, and then I'll provide some information on how you can get started with Azure ML and machine learning. A little bit of background information about myself. I've been working on the Microsoft BI stack since 2007, and as GNet Group's North American data science lead, I've been working with Azure ML since it was still in preview mode last year. So I'm lucky enough to have seen this product mature and to see it launch into general availability, and hopefully some of the lessons and experiences that I've picked up along the way can be passed along to you as you try to jumpstart your own path with machine learning. I attended two local universities here in Minnesota in order to get my formal education, but most importantly, I've done a tremendous amount of self-directed learning in both business intelligence and data science. And I'm very adamant that anyone can get into these fields if they put in the time, put in the effort, and take advantage of a lot of the resources that are out there and available to leverage in order to become a data professional. If you'd like to network, you can either reach out to me at my Twitter account, which is @grbeaumont, or also on my LinkedIn page. So for those of you who are new to predictive analytics, what is machine learning? I'll stick with the standard definition from Wikipedia, which says that machine learning is a scientific discipline that explores the construction and study of algorithms that can learn from data. Such algorithms operate by building a model based on inputs and using that to make predictions or decisions, rather than following only explicitly programmed instructions. So basically, you're creating a model that then uses your data to establish relationships which can make predictions. There's a lot of buzz out there right now about terms such as machine learning, data mining, data science, AI, and big data. I thought I'd put together a quick slide to show how I see them all fitting together so that it might help you navigate the landscape as you're teaching yourself to get into data science and machine learning. So I see data science as being a subset of statistics that specifically focuses on stored information or stored data and uses the scientific method, including statistics, in order to try to uncover and determine relationships within the information. And predictive analytics is then using that information in order to make predictions about things like classification, about forecasting, and about trying to draw conclusions from relationships that existed in the past, maybe as it pertains to new data. Machine learning is a specific approach that uses historical data to build a model and then makes predictions for the future. So there's ways of doing predictive analytics that are different from machine learning. So it's definitely a subset of predictive analytics. And then data mining, from what I've read and what I've studied, is basically a subset of machine learning tools that serve a specific purpose to establish relationships within data. So those of you from the old analysis services world where there were SSAS data mining tools, you were basically doing a form of machine learning at that time. A term I don't like very much is artificial intelligence. I don't believe that the word intelligence is adequately defined. And that is basically the study and design of intelligent agents, and you'll hear a lot of buzz about that word also in the news, because there's a real impact marketing factor to predict that we're creating machines that can think. So I'm a little bit skeptical about that, and to be honest, I'm not qualified to make any type of predictions in that area, but that is something which you'll hear used frequently along with some of these terms. And then also big data, which you frequently can do data science and machine learning with. However, big data is not actually data science and machine learning. It is a term used to describe massive volumes of information, most of which is unstructured, but it could also be structured if there's just very large volumes of information. So machine learning is not something that's brand new. It's been around a long time. It's just become easier to use and more affordable. And there's a lot of existing success stories out there. So speech recognition technology, such as Siri and Cortana, those are based primarily off of machine learning algorithms. Spam filters, Microsoft over 10 years ago had spam filters in Hotmail that were based off of machine learning. Recommendation engines, so if you see something to the effect that people who bought this also bought this, you see that frequently on Amazon. That's due to machine learning algorithms. Handwriting recognition, the post office uses machine learning in order to recognize handwriting on letters that you've written. News story clustering, so the ability to find similar news stories and put them into aggregators so that the news you're reading is related. Credit fraud detection, so when you get a call from your credit card company and they ask you, did you make this purchase on this date for this amount at this place, it's usually because that purchase triggered some sort of anomaly detection algorithm, which is looking for buying events that are outside of your usual behavior patterns. Self-driving cars use a lot of algorithms and are constantly accumulating data that can retrain models and make the self-driving cars better at self-driving. And robotics also. So if you get a chance to go search YouTube or a search engine for Boston Dynamics Atlas, it's a company owned by Google, and they're making some very innovative and interesting to watch robots that will probably have an impact sometime in the future. And I'll talk a little bit more about image recognition, but that's also going to be something that's primarily based off of machine learning algorithms. So I can give you a quick demo of a nice image recognition technology that you can try right at home. It's actually a lot of fun and quite useful. In Google Images, you'll see that there's a little camera here in the search bar. And if I hit that icon and I go to upload an image and I browse the files on my computer, you'll see that I have two pictures uploaded of a dog that my wife and I adopted that's half poodle, half golden retriever, otherwise known as a Goldendoodle. And these pictures have not been pre-indexed in Google or any search engine. They're just pictures taken with my smartphone. And I'll go ahead and upload one of the pictures to Google Images, and you'll see that it runs the picture through a machine learning algorithm or possibly series of algorithms. I don't know what the specific setup in the background is. I'm sure that's a proprietary application, but you can see that similar images come up, many of which are probably Goldendoodles or Labradoodles. Looks like several poodle mixes. It's definitely identifying that the picture is a dog, but it's also finding pictures of dogs that look very similar to that dog. Now, looking at the picture of our dog that was used for that search, you'll see that it has a traditional Goldendoodle haircut. If I were to use a different picture where we've now given the dog more of a Schnauzer type haircut, let's see how the results differ. So moving back here to the search application, if I upload the other picture that I have of our dog, and you'll see that it runs through the machine learning algorithm, now you can see that it's still identifying that it's a dog, but it's pulling up some different types of dogs. So I don't know for sure, but my guess is that by having an atypical haircut on a mixed breed dog, threw off the ability to be precise in the types of pictures that were coming up. So now that we've reviewed a little bit of background information about machine learning, let's get to the point that most of you are probably watching this webinar for, which is how do you use machine learning and predictive analytics in order to create value for either the organization you work for your own business, for a research project that you're doing, or to be able to have it answer real world problems and to have access to a machine learning technology that you can use to create value. So let's start by reviewing the decision making process today that you typically see in an organization. So typically in an organization, when there's a business issue, a business leader will look at data to understand that issue. And they'll ask themselves what they know about that issue. If it's something they've seen before, that's common in the organization, or that they're familiar with, they're going to have some intuition about that issue that they can use to make a decision. If it's a new issue, or if it's a complicated issue, or something they haven't seen before, they're going to want to know more about it, and they're typically going to go and ask other people about that issue. And they may also talk to analysts and say, spin me up a pivot table in Excel in order to try to get to the bottom of this, or go to IT and ask for more reports to be developed. And anybody in business intelligence has probably been in a situation where you keep creating new and revised reports that get better at answering the questions that you're looking to solve, but don't quite get to the heart of the problem. But all of those things then play into a decision, which becomes part of lessons learned and then feeds into the entire process the next time around. So machine learning fits into this process in an organization or an institution, a small team that's working to solve problems. So with machine learning, what you're attempting to do is to take the factors that leaders look for when they're using their intuition and building those into a programmatic algorithm. So if you're looking at a population of customers, you might look at what part of the country it's in. Historically, do people on the East Coast behave differently from people on the West Coast? Based on recent weather trends, a certain product might have a different forecast than originally was thought. And those types of things can then be evaluated in the data and built into a machine learning model, which can programmatically contribute to the ability to make decisions. So taking decisions which are typically done by people and building it into an algorithm that allows you to scale it and to make that decision numerous times without having to rely on individuals in the organization. You can also use the output from machine learning models in order to evaluate how well they're working. So this isn't just a black box where you're coming up with a bunch of predictions and you don't know where they came from and you have no idea if they actually worked. You can actually programmatically compare the results of a machine learning model in order to determine if it's doing the job and how accurate it actually is. And then all of those things will also play into the lessons learned so that the entire process becomes better the next time around. So here's a concept you've probably seen and probably heard of in a lot of different analytic presentations, but one of the things that machine learning is looking to do is to find that needle in the haystack. So it's very easy to look at a particular chart where you're looking at what happens over time and what happens in different groupings of categories within your data. But when you start looking at all of the different combinations that you can slice and dice, when you bring in the customer dimension, when you bring in the product dimension, looking at geography, looking at different individuals in the organization that have different responsibilities, it becomes functionally impossible to manage and fully understand. You can't have enough people to look at every possible combination of the data in order to determine where is that needle in the haystack. And another nice analogy is if you think about something as simple as a frog. How does a frog know what it wants to eat? Looking at a cricket, it's probably some combination of color, movement, size, shape, those types of things. But if you think about it, in many ways it works like a machine learning model. The frog has a predefined algorithm that gets filled up with data as it experiences the world, and based upon things that it experiences, the algorithm tells it to strike or not to strike. And those types of intuitions took millions of years to evolve. But if we're talking about human intuition in business strategy, those things evolve way too fast for evolution to keep up. So businesses don't have time for the evolutionary learning of intuition. Businesses need revolutionary learning, which is going to be machine learning and the ability to modify the decision-making process in a rapid and iterative way. So since we're focusing on Azure machine learning, Azure ML. From the Microsoft perspective, machine learning is computing systems that become smarter with experience, where experience is historical data along with human input in order to make the model better. And if you look on the right, that's actually delivering on one of the old dreams of Microsoft co-founder Bill Gates, according to John Platt, a distinguished scientist at Microsoft Research, that computers can see, hear, and understand. So you're using these machine learning algorithms and models in order to see, hear, and understand what's going on in the business, or what's going on in your experiments, or what's going on in the things that you're monitoring in order to help you make better decisions and improve outcomes and quality and the like. Microsoft has very deep experience with machine learning, going all the way back to 1991, as you can see on this chart. As I mentioned earlier, Hotmail had spam filters as early as 1997. Bing Maps has a lot of machine learning algorithms. Search results often contain machine learning algorithms. Microsoft Connect is using machine learning, also Skype Translator. And basically, Microsoft is bringing this vast, deep history of machine learning and putting it under one umbrella with Azure ML so that you can start utilizing it for your business problems, your scientific problems, and the needs that you have from your data. So why hasn't machine learning been more readily available to a lot of organizations out there and to individuals? First of all, it's historically been very expensive. It is widely used, and it has been widely used by very large organizations that can afford very expensive infrastructures and very expensive employees in order to manage those infrastructures and to build out the traditional types of machine learning models. Additionally, data is very siloed and can be hard to get to. Tools are very disconnected. A lot of the old school machine learning tools don't readily integrate with a lot of the plug and play data analysis tools that business analysts will use. And it's also very complex. So there was a lot of custom coding needed in order to build out models. And because everything had to be done in-house on an internal infrastructure, there were a lot of moving pieces involved in order to get things right. So how does Azure ML and the Microsoft BI stack fit into the decision-making process that we discussed earlier? The data could be coming from a data warehouse, cubes, anywhere where you're able to get information within your organization. And the reports and the reporting that we talked about could be Excel if people are building custom pivot table reports, could be reporting services if there's standardized reports that you can look at in order to get to the bottom of an issue, or you could be looking at dashboards such as those in a tool like Power BI. The programmatic intuition using machine learning would be done with Azure ML, and that's where you could build the model, train the model, test the model, tweak the model, and then score the model. And once you've done that, you can then test the model. And with a setup as simple as Azure ML and Excel, you could build machine learning models, use the machine learning models, and then also test them in Excel in order to tweak them and make them better by understanding what parts of the model could be improved upon. I'll show this as part of my demo in just a little bit. Looking at a slide here which shows Microsoft's vision of the modern data warehouse, notice at the bottom for data sources, there's your traditional data sources such as ERP and CRM right on the left-hand side. And then there's also non-relational data, which is often referred to as big data, where you're looking at unstructured data and data that's coming from different sources such as sensors. Moving all the way to the top, you can see that it's advantageous to classify the different types of reports depending on who the users are and what the context of the report is. So, for example, self-service reporting could be something that's done in Excel using pivot tables and pivot charts where you're hitting a tabular model sitting in analysis services, or a Power Pivot model that's being shared by a team. Corporate reporting, such as that done with reporting services, where standardized reports can be emailed out to users at specific time intervals. Collaborative reports, such as those in SharePoint, where you have version control and small groups can work on a project. Mobile reporting, and then also machine learning. All of these things are in the context of the modern challenges, such as real-time data, increasing data volumes, how to integrate the cloud and when to integrate the cloud, new types of data, the sources and the types, such as big data. And all of this becomes part of the reporting challenge that organizations are facing in order to determine the path that's right for them. From a high-level perspective, Azure ML is 100% in the cloud, which is one of the advantages of this product because there is no on-site hardware or software required in order to integrate it into your infrastructure and into your processes. You can see here that it can be used in a couple of different ways. So you can use it to do bulk predictions, such as you'd want to do with forecasting in order to do predictions on large volumes of data and then take the results and put them back into your data warehouse or source systems in order to use them for reporting and use them with standardized reports. You can also use it in real time on the front end in order to take new data and make predictions and effectively integrate it into processes that happen quickly where you don't have time to send the data back to the data warehouse and wait for everything to process and work its way through the entire infrastructure. A couple of examples here that have been provided on slides from Microsoft. One would be smart buildings, which was done by Carnegie Mellon University, and using Azure ML, they were able to programmatically optimize the heating and cooling systems in real time. So using historical information, they were able to build models that could then help them automate the process of optimizing their systems in order to save money and save energy. Pier 1 Imports also used Azure ML in order to do a recommendation engine type approach. And you'll see there in the quote that they were especially pleased that the analysts could focus on results and not worry about the complex algorithms behind the scenes. This is one of the values of Azure ML, is that your business analysts and beginners can get started with the product without having a tremendous barrier of entry in order to get going. Some additional use case scenarios where Azure ML could be a valuable tool. In manufacturing, looking at warranty and claims, you could look at past warranty and claim data in order to predict future trends and also to be able to predict what types of situations cause warranty and claims to happen. Within manufacturing, if you're operating lean, you can take data from samples during production in order to predict waste and batch quality. Machine component data, there's all these different components sitting in a factory that are basically streaming information. A lot of that information isn't even being captured. With machine learning, you could start monitoring some of that information in order to proactively monitor performance in order to prevent downtime. In healthcare, the possibilities are absolutely endless in healthcare, and that'll be the second demo that I do as part of this webinar, is a healthcare demo. Looking at patient visit data, looking at electronic health record data, looking at diagnosis in order to predict comorbidities, looking at lab data in order to predict future diagnosis, using process data during patient visits to monitor best practices and performance measures. The list could go on and on. In marketing, you could also take unstructured data from APIs, reaching out to social media sources such as Twitter, LinkedIn, and Facebook in order to make predictions about campaigns and engagements. You can also monitor sentiment in the text in order to determine if something negative is being said about a particular product that you might make. In logistics, almost every organization is impacted by the weather, and using machine learning, you can predict your ability to deliver things on time and basically mash up that weather data with your historical data in order to determine situations that are impacting your ability to meet promises that you may have made to customers. In retail, as we mentioned earlier, there's the recommendation engine, such as you see on Amazon. You can also do market basket analysis, which is understanding what products will sell well when placed near each other. Also looking at historical information in order to inventory forecasting, and attribution analysis in order to determine the best combination of web page visits in order to drive a purchase. Within Azure ML, there's 4 basic categories that the algorithms fall into, and I can talk about those a little bit. The first is anomaly detection. This would be looking for something that falls outside of what's considered normal or what's considered typical. And an example of that would be when you get a call from the credit card company asking you if you made a purchase at this place for this amount at this time. Clustering, which is basically looking for groupings of individuals or groupings of items or groupings of any type of category where things have a similar behavior pattern based upon specific details that you specify. Also classification, And that goes back to our analogy of the frog and deciding when it's actually going to strike. So classification takes information and it gives you a yes/no prediction along with an indicator of how confident the model is in that prediction. And finally, there's also regression, which is for the most part in a business setting going to be forecasting. It's using past information in order to project trend lines out into the future. So here in Azure ML, we're looking at an actual experiment that I created a little while back, and it's part of a demo that I'll be showing in a little bit. On the left-hand side, you'll see several groups of items that you can use to build out your experiment. Under machine learning, if you open up Initialize Model, that's where the 4 classifications of different types of algorithms that I previously discussed are located. Under anomaly detection, there's some pre-built algorithms that you can use. Under classification, there's numerous pre-built algorithms. Under clustering, you have the ability to do k-means clustering, and under regression, there's also a number of different options that you can try out. If you're an experienced data scientist and you'd like to write out your algorithms in custom R code, you could also bring in the ability to do a custom R script. So here you can see that you could actually add your custom R code and do everything on a customized basis so that you know everything that's happening to your data in the experiment. If we wanted to try a different pre-built algorithm other than the 2-class decision forest, let's go ahead and open up classification, and we will try the 2-class logistic regression. Let's delete the 2-class decision forest, bring the new one in, make a connection, a lot like you would with an SSIS package, and then you can hit the run button. And when you do that, you'll see that the experiment goes ahead and runs. And it looks a lot like an SSIS package. You get a green arrow when things are successful, and it's already finished. And down at the bottom, you can see you can also get some evaluation information about the model in order to see how good of a job it's doing. And this one is looking very good with the lift chart. The further towards the upper left corner of this chart, the better. And the accuracy is 93%. I'll come back to this in a little bit when we get to the demo for this particular experiment. The first demo that I'll show today is in regards to a retail marketing campaign. The first data set used in the demo is historical customer data that includes demographics and information about the customers who have previously bought a product in the past. So these are basically customers who responded to previous marketing campaigns, and it gives you an idea of who responded and who didn't, along with some descriptive information about those customers. The second data set is a list of potential customers for a new marketing campaign. And this list in the demo is for 18,000 potential customers who are within 10 miles of a specific retail location, and it could be queried from a large database such as the Microsoft APS. It also contains similar demographic data. And just as in the real world, there's going to be some limiting factors that affect an organization's ability to successfully execute a marketing campaign. The first being that there's only $100,000 left in the sales and marketing budget, and there's an average cost of about $60 per person for marketing activities. And these would include things like Twitter, LinkedIn, Facebook outreach, mail campaigns, different types of things that you can do to reach out to your customers. Additionally, there's a goal of generating $90,000 in total net profit in order to meet the sales goal for the year. So that's $90,000 in additional profit that are needed for a company to meet its revenue goals. On top of that, the sales team and the marketing team, they only have enough people power and budget to reach 2,000 potential customers. So here we're looking at the historical marketing campaign data in Excel in a business intelligence report. Everything that you're seeing here was developed in Excel 2013. On the left, you can see that there's some slicers to start taking a look at the data interactively. And if we were to take a business intelligence approach and only look at individuals who have a bachelor's degree, you'll see that the percentage of people who purchased a product, which is the green bars, varied by income versus those who did not purchase the product, which is the orange bars. Looking at age group, you'll see that as the customers got older, the likelihood of purchasing decreased. Looking over on the right-hand side, we can expand this graph, and we can see that with income average on the y-axis and age average on the x-axis, that there's a variance amongst different professions and how the demographics break down for different types of individuals. You can see in the clerical profession that the individuals who purchased the product were much younger and they also had a fairly consistent income versus those who did not purchase a product. So age was much more of a factor for that profession. Whereas some other professions, there really wasn't much of a difference between those who did purchase the product and those that did not. Let's go ahead and collapse that graph back down. And then if we were also to look at just occupation in general, you'll see that people whose job classification is manual were much less likely to purchase a product, whereas clerical were much more likely to purchase a product. Now, looking over here on the right-hand side, you'll see that there's actually numerous different types of things that we can filter this data set by. So whether you're looking at whether or not they own a home, what the marital status is, what their occupation is, and the like, there's a lot of different things to look at. So if you were running a marketing campaign and you wanted to take that list and predict who was going to buy a product from you, where do you start? There's so many different things to slice and dice by. There's a lot of different ways you can filter, and business intelligence is a very powerful and very useful tool, but it's not designed to give you a targeted list of the people that you need to reach out to in order to meet your marketing campaign goals. That being said, once we've discovered some different factors that influence purchasing probability, we can then create some data to be uploaded to Azure ML. Here you'll see that the features that we uploaded to the model were as simple as a ID for the individual customer, along with age, number of children, income, number of cars, commute, education, gender, home, and a few other things. Now, you'll notice that this is not your entire data warehouse and that there's no customer sensitive information here. These are anonymous IDs which cannot be tied to an individual person that might be considered a security compromise. So this information can be then uploaded to Azure ML, and you can use it in order to create a machine learning model. So once you've used that data to create a machine learning experiment, you can use some additional historical information in order to determine how well the model that you're building will work. So in this example, what we've done is taken month 1 and month 2 of the customer historical marketing campaign results data, and then used month 3, which was not part of the model, in order to test how good of a job it did at predicting whether or not somebody would buy a product during a marketing campaign. And we're using something similar to signal detection theory in order to test that accuracy. So you can see here that the model was correct about 81% of the time. I'm going to go ahead and make that text a little bit darker so you can see it in the video. And 81% is pretty good for machine learning. They generally say in some of the white papers and articles that I've read that 70-80% is a pretty good result, and if somebody's getting close to 100%, you might want to be a little bit skeptical about those results. And so you can see here that of the 405 that were scored correctly, 217 were true negative, which means you predicted that they would not buy a product, and they did not. And 188 were true positive, which means you predicted they would buy a product, and they did. And within the incorrect, you also have false negative, which means you predicted that somebody would not buy a product, but then they did. And false positive, which means that you predicted somebody would buy a product, but they did not. What's nice about then bringing these results into a business intelligence tool, you can open up something like the false negative, get that customer ID, and then slice the report by that individual customer in order to take a look at what some of the different values for that customer were and where they fell within the different features that you uploaded to your machine learning experiment in order to determine where the experiment might have gone wrong. So the idea here is that you can not only create a model that makes predictions for you, but you can analyze the predictions that were not right so that you can go back to Azure ML, modify your model, try out some different algorithms, and do what you need to do to try to make that model better so that you can do a better job of predicting even than 81%. Once you've created a model with results that you want to use on a production basis in Azure ML, you can then publish that model to be used as a web service. I'll go into a little bit more detail about that in the next demo. With a published model, you can then run those 18,000 new customers through the model in order to make predictions on who is going to be a likely buyer of the product for the marketing campaign. Those results you can also pull into Excel and do a little bit of analysis on in order to see what type of results you're going to get from your marketing campaign. So of those 18,000 plus customers, About 47% of them would be buyers if you were to do outreach to all of them. The sales activity cost would be a little bit over $1 million. And if you remember, the budget was for only $100,000, and there would be a net gain or net profit of about $200,000. Looking over on the right, you can see if you focused only on individuals who were predicted to buy, about 75% of them would actually buy, and the cost would be about $500,000 with a net gain of a little over $460,000. So basically, you're cutting your expenses in half and doubling your profit just by using the machine learning model in order to predict who you should reach out to. Now, we had those other factors in the marketing campaign that limited your ability to reach out to everybody. So let's use the business intelligence capabilities in Excel to cut this list down a little bit. If you only looked at individuals who had a bachelor's degree and who lived within 1 mile of the store, you'll then see that if you were to reach out to the individuals who were predicted to buy, that there would only be a little over 1,500 people in that group. About 82% of them would actually buy the product, and you would have a cost that's under $100,000, so that would be a manageable number within your budget, and your net gain would be $97,662, which gives you the $90,000 that you need in order to make your sales goal for the year. Now, in the example that we showed, the predictions were made on a bulk list of customers that were taken from a large data source in order to predict who you should include in your marketing campaign. You can also use the published machine learning algorithm API in order to make predictions on individual rows of new data. So if, for example, a salesperson were meeting with individual customers and entering in some demographic information as they talk to the customer, you can see here right in Excel that if you changed the number of cars from 0 to 2, the probability changes a little bit, and if you were to change the age from 40 to 70, the scored label goes from 1 to 0 and the probability is down below 20%. So that customer would no longer be someone who is predicted to be a buyer. These predictions can thus be made in near real time with new data that doesn't yet exist in the data warehouse. So let's compare a couple of the different options from this particular demo. If you were to include all 18,000 people in the marketing campaign, the cost of doing so would be over $1 million, which exceeds your limit of $100,000. If you were to have the sales and marketing team randomly call on the max allowed by budget, 47% of them would buy, and you would only increase your net sales or net profit by $18,000. If you were to use Azure ML along with Excel to isolate 1,555 likely buyers, the result would be that 82% of them would buy, and you would have a net profit of over $90,000. So you'd meet your sales goal and you'd stay within the parameters that you have to work within. To look at that on a KPI scorecard, since many of us are business intelligence professionals, we like scorecards. If the campaign was to every person on the list, you would make your net profit, but you wouldn't be able to have that many people in your marketing campaign due to budgetary constraints. If you randomly chose 1,667 people, you could pull it off within budget, but your net profit wouldn't meet your goal. If you were to use Azure ML to predict the people most likely to buy from the marketing campaign, you could stay within your budget, you could realistically reach out to all of those people, and you could also meet your net profit goal. Now let's move on to our second demo, which is looking at using machine learning and Azure ML to predict whether or not breast cancer biopsies are malignant. First, let's review the data used in this demo. It is the results of real breast cancer biopsies that was released to the public via the University of Wisconsin. There are over 500 biopsies in the dataset, and we will use 10 measurements from the dataset for the machine learning model. I provided a citation for the data on this slide. You can access the data for your own use at the University of California, Irvine Machine Learning Repository. More information about the data is available at this site, including links to publications that reference the data. On this tab, you can see the data as it appears in the source, which is in a flat file type format. Here in Excel 2013, I've imported and formatted the data from the UCI repository. After modeling the data, we can analyze it with a dashboard built in Excel. This tab analyzes one measurement, radius. On the top graph, orange bars are a count of malignant or cancerous biopsies. The blue bars are benign or non-cancerous biopsies. You can see that as the radius goes up, the likelihood of malignancy also goes up. The lift chart on the bottom right affirms this observation. The further apart the two lines are, the greater the ability for radius to predict malignancy as it increases in value. You can see that a similar relationship exists for the measurement texture on this tab, and a similar situation also exists for the measurement perimeter. Let's look at radius and texture on a modern Excel scatter chart. With texture on the y-axis and radius on the x-axis, you can see that there is a greater likelihood of malignancy as both values increase. The blue colored biopsies are benign and the red colored biopsies are malignant. There's this middle region with quite a bit of overlap. Let's add perimeter to the play axis. By hitting play, you can see that that middle area exists within the relationships between all three measurements. So we have 10 measurements that we're looking at. How can we possibly evaluate whether measurements from an individual biopsy are malignant? With traditional business intelligence and data analysis tools, such a determination would be very difficult, if not impossible. Here's where the use for machine learning comes into play. Moving down to the last Excel tab, I've organized a pivot table to contain each biopsy number on a single line, with the diagnosis, the 10 measurements, and a binary representation of the diagnosis. Here in Azure, I've uploaded the data from that pivot chart and built an Azure ML experiment with it. This is a very simple, basic experiment that uses a two-class logistic regression with the 10 measurements in order to predict malignancy. The tested output of the resulting trained model can then be exported to Excel to determine the accuracy of the predictions. We've imported the test results of the trained Azure ML model. Rows of biopsy data that were not used to build the model were run against it to test for accuracy. You can see the distribution charts for the 10 measurements on the right-hand side. The lower pivot table contains the scored results of the tested Azure ML model. Correct predictions were either true negative, which means that the model correctly predicted a biopsy to be benign, or true positive, which means that the model correctly predicted a biopsy to be malignant. You can see that the Azure ML model was correct about 93% of the time. The incorrect predictions were either false positive, for which biopsies were incorrectly predicted to be malignant, or false negative, where biopsies were incorrectly predicted to be benign. This is probably the worst scenario because cancerous biopsies were predicted to be non-cancerous. Using modern Excel, we can look at the biopsies that were false negatives and do an analysis to find out why the prediction was wrong. Having selected one of the biopsies that ended up being a false negative, you can first of all see for that row that the confidence of the prediction was 33%. At 50%, it would have predicted that biopsy to be malignant. So it was on the higher end of the negative results. You can look up here at the measurements of that particular biopsy, and you can see, for example, that the radius was 16.02, and that falls towards the high end of the benign radius values. Texture, 23.24. Same scenario there. It's more towards the upper end of the benign range for the texture values. And let's just go ahead and move down to the last one, fractal dimension. So for fractal dimension, you can see that it was at 0.057. And looking at 0.057, it's a little bit further to the right, but you can also see that there's a less of a trend towards malignancy as you move up in the value of fractal dimension. So let's look at that particular measurement once more and take a look at the lift chart. And on the bottom right, you can see that those lines are actually a little bit closer to one another, which indicates that there maybe isn't such a strong relationship for increasing malignancy with an increasing value of fractal dimension. By analyzing the incorrect predictions, the Azure ML model can be adjusted to make better predictions in the future. The model that I built and that I showed you was very simple, and there are opportunities to try different algorithms, normalize the data, and add other additional steps to make that model better. Once an Azure ML trained model is deemed good enough to use in production, it can be modified so that it's production ready and then published as a web service to use with new data. The model can be called using an API, so it's platform neutral. Once you have a trained Azure ML model published as a web service, you can use it in order to make predictions with new data. In this example, the model is used to evaluate single rows of new biopsy data right in Excel. So I've basically built an app right in Excel. A prediction of benign or malignant can be made for new rows of data. Right now we're looking at the averages for all 3 new rows of data. If we were to select the first option, you'll see that the Excel app actually passes an API call to the web service Azure ML model. We can also get that prediction for the next row of biopsy data or the final row of biopsy data. And you can see that it brings in the 10 measurements that we're evaluating along with the diagnosis prediction and also the scored probability of how confident that machine learning model is in that particular prediction. So I can quickly show you how this app works in Excel. Basically, it's just using some logic within Excel to call the Azure model and to feed these values to that model in order to get the prediction on new data. So for example, if the texture instead of being 25 were 28, you'll then see that the output will change along with the scored labels and the scored probability. And by changing that value, it will receive from Azure a new diagnosis of malignant because the scored probability was over 50%. In a production setting, professionals could evaluate biopsy data using this Excel app or something similar to it as a diagnostic aid to help them evaluate new results. This method of using Azure ML as a machine learning service to make predictions on new data can be applied to countless scenarios in a healthcare setting. So let's review some of the ways that Azure ML brings machine learning to the masses. The first is on price. You can get started with Azure ML with an Azure account, and you even get a free limited amount of usage per month. So you can get going without much cost at all. Traditionally, you had to have an infrastructure and personnel to maintain that infrastructure before you could build out anything using machine learning. Secondly, a lot of the traditional machine learning tools require a very high level knowledge of statistics in order to get started. Now, it's probably a good idea to have some statistics background to get started with Azure ML, but individuals who have a college level understanding of statistics can probably get started without having to have a PhD level in order to use this tool. In regards to programming language, older tools required knowledge of languages such as R and Python, whereas with Azure ML, there's some pre-built modules, so you can build simple models without having to use any code at all. Long term, it's probably a good idea to learn how to write R and Python in order to build more advanced and complicated models, but you can get started without that huge barrier of entry. Also, as mentioned before, the infrastructure is 100% in the cloud with Azure ML, so there's no need to have on-site servers, software upgrades, those types of things. It's all taken care of for you. And finally, there's that API where you can call the model. The API is platform neutral, so it works with any tool that's able to call an API. You can call Azure ML models from websites, you can call them from Excel, from different types of business intelligence tools, and it's completely vendor neutral and in a easy to use API format. So let's take a look at how machine learning has been available to individuals within organizations from a traditional perspective. So experienced machine learning users are people who usually work for large high-tech companies or universities or working in an academic setting, and they're going to have access to these types of tools that have been around a long time. Larger low-tech companies will have some access to machine learning, but because it's expensive, that can vary depending on where you're at. Mid-sized companies probably also some exposure, but not full exposure. And small companies and entrepreneurs could probably use machine learning if they had the knowledge, expertise, and access to the software and hardware that they needed in order to get going. Now, in large companies, the new and inexperienced machine learning users could get some access to machine learning, but they probably don't have the level of access that the experienced, specialized data science team would have. Low-tech companies, from our experience, they typically don't have access to machine learning tools if they haven't used them in the past or if they're inexperienced. Same thing with mid-sized companies, and same thing with small companies and entrepreneurs who don't know much about machine learning or how to get started. Now with Azure ML, it's going to lower the barrier of entry for both experienced users and for new and inexperienced users. So those experienced users who are in low-tech companies can now have access to more robust machine learning capabilities with Azure ML. Same thing with mid-sized companies, and small companies and entrepreneurs will be able to not only afford the technology, but get started with the technology without having a larger barrier of entry with regards to their education. With new and inexperienced machine learning users, they'll also be able to get full access now to machine learning within a large high-tech company and low-tech company. And with mid-sized companies, realistically, they probably could get access, but from our experience, there's so many requirements already with business intelligence and other types of reporting that it will probably depend on the scenario. And with small companies and entrepreneurs, those new and inexperienced users can also get going right away. So signing up and getting started with Microsoft Azure ML is very simple and very easy. If you don't have an Azure account, you can sign up for a Microsoft Azure trial. Over on the left-hand side, when you're in Azure, you'll see the Erlenmeyer flask with the title Machine Learning. You can go to your workspace and go ahead and sign in. And once you're signed in, you have access to all of your experiments. Now, when you first sign up for your account, there won't be any experiments here, but if you'd like to get started and look at some existing examples, click on the New button down here in the left, and there are quite a few existing Microsoft ML experiments and solutions which Microsoft has made available to you here to get started with. So if you want to take a look at how they're doing anomaly detection for credit risk, you can just click right here, open it in the studio, and then you can learn by trial and error as to how the data scientists at Microsoft have been building different types of solutions. It's a great way to start learning something without having to start from scratch. Another differentiator with Azure ML is Azure ML Marketplace. Azure ML Marketplace allows you to monetize machine learning models that you've created, which you think other people would want to buy from you or rent from you. So basically, there's already numerous machine learning models available that you can go ahead and use. So you can get the benefits of machine learning without having to build the actual model. You can also publish your own ML models and then license them out to other people. Basically, this is an app model for machine learning. So companies can buy and sell machine learning models, and the cream is going to rise to the top. Individual developers and entrepreneurs have a worldwide forum for their models. This is a lot like apps for mobile devices, and that the good ones are going to be used frequently, rated well, and become popular, and it gives everybody a shot to go ahead and build a better mousetrap. Taking a look here in Microsoft Azure Marketplace, you can see that there's a lot of different options that are already available. So you have things like customer churn prediction, text analytics, frequently bought together, anomaly detection, and more. If you'd like to learn about pricing for Azure ML, Microsoft provides a calculator where you can try to figure out how much it'll cost you to use this service. The link below can also be easily found by searching for Azure ML Pricing Calculator in a search engine. One thing that I ask people to do after seeing this presentation is to think about issues that they face in business, in work, in science, and in all aspects of life differently. So when there's a problem that's difficult to solve, could you solve it by adding machine learning? One example would be if your sales team is currently looking at dashboards, which is showing them how close they are to their sales goal. With machine learning, you can now give them a list of people who are likely to help them meet their sales goal. So it's taking your data and rather looking at it from a retrospective perspective, you can use your data in order to make actionable decisions in the future that are going to help you get where you need to go. Another example was recently I was looking at trading in my car. The car dealer wanted to figure out how much to offer me for my old car, and in order to do that, he first looked up the value of the car on Blue Book, and then he got a thick ream of paper and he started paging through it. And he was trying to figure out if he brought that car into his dealership, how long would it sit on the used car lot? Because that's just money tied up in inventory that they can't use in their cash flow. So that would be another example where you bring in data for both Blue Book pricing and additionally for how long vehicles have been sitting on the lot, and you could use machine learning in order to give a nice prediction based on make, model, color, mileage, those types of things as to what they'd be looking at from a cost and from a time on lot perspective. Another opportunity is going to be at restaurants. So right now a lot of sales at restaurants are probably based off of strategies that are set ahead of time, but with machine learning you can start setting strategies based upon real time. So based upon what the weather might be, you might want to offer hot food versus cold food as a special. Based upon what might be expiring soon in inventory, you might want to put those things on clearance. Some of these things can be hard to track manually, so by looking at how crowded a restaurant is, if you want to increase or decrease churn, and additionally what type of other factors are influencing decisions, you can start increasing your revenue by using data in that manner. With marketing, the possibilities are endless. You can start conducting marketing campaigns, as we mentioned earlier, using your historical data in order to chart the course forward. You can start planning the type of content for your articles based upon past performance. You can start figuring out which hashtags are going to work for different types of articles. And there's just a lot of different directions that you can go when you start thinking about machine learning as an option to solve problems. Thank you for attending the webinar today. If you have any questions, you can go ahead and contact me at my Twitter account, which is at @grbeaumont, or on my LinkedIn account. If you'd like to contact GNet Group about our consulting services, please check us out at either gnetgroup.com, or you can read some of our articles at blog.gnetgroup.com.